Welcome everyone to the second lesson here in Chapter 6, Lesson 6.1.2, How Can I Move a Shape on a Grid? Now what we're focusing on today is directions on the coordinate grid. Yesterday we were kind of introduced to these notions on our computer screen so that we can kind of get familiar with the directions. But today we're going to focus on how is it actually happening on paper on the coordinate grid. Now where do we see this happening in real life? We see it happening on a map. Okay, remember the world is a map. The x-axis is the equator, the y-axis is the prime meridian. If you don't know that, we need to work on geometry. And the rest of our world is broken up into longitude and latitude, which is our x and y axis. And we are just mere shapes on that grid. And so what we're going to work on today is focusing on those directions. Now, one of the key things I want you to notice is yesterday, there are different answers to get the same result. Problem 6-8, our first problem, has multiple answers. You just have to come up with one of them to get the triangles to work. So we're going to focus on how do we get there. So our first problem, while solving the key challenge in 6.1.1, Rowan made more than one move to change his key from A to B, and then our second problem, from C to D. Remember, A to B, C to D, okay? We can see these triangles. And what we're going to do is we're going to focus on how do we slide, also called translations, turns, also called rotations, and flips, also called reflections. You can remember these in a list. SL, SL slide. T, T turn. FL, FL is our flip. That's how you can remember the connection in those words. Okay? So we're going to slide, turn, and flip. Here we go. So notice that you have a triangle around the key. It's easier to draw a triangle than it is to draw a key. And our goal is to move this triangle over here somehow. Okay? Notice, can't go into the wall. Can't go into the wall. You have to go around. So, you have three rigid transformations at your fingertips. You can slide x plus or minus. Plus is to the right, minus is to the left. Y, plus is up, Y is down. You could flip. If you're doing side-side flip, you need to tell me x equals number. If you're doing a top-to-bottom flip, you need to tell me y equals number. And last of all, a turn, you have to tell me how many degrees, clockwise, counterclockwise. Your job today is just like the key lock puzzle. Now, if you're really stuck, maybe you should look at these problems that are in CPM, and you could try the key lock challenge, try it on the computer, and then draw where it lands. That's one source that you could use. So your job, get A to B, and you'll notice in your notebook there are lines off to the side for you to record your work. Step number 1, do a slide. Maybe you get to a turn. Maybe you try flip if you're really confident. So you are going to do A to B, and then you're going to do C, getting it to D. Okay? You got to work your way around it. Okay? That is problem 6-8. You can do it. Pause the video for you to go ahead and get A to B and C to D. Now, for problem 6-9, we're going to jump over to the document camera so that we can go ahead and put our information here on our paper. I think it's easier to work with. So, step number 1, what I need you to do is draw this triangle. We're going to start with triangle ABC with coordinates 5, 0, -5, 3, and -1, 0. So let's plot those points now. And I'll do my best to keep my ugly hands out of the way. So here's A, B, and C. Now, what we need to do is we are going to imagine that I have a set of directions, but I don't know where the key lock is. So what we need to do is follow this set of instructions so that we can get to the key lock. Step number 1, we need to do a slide x plus 4, y plus 2. Okay, that is going to be our first rigid move. Now, in class we use something that is called parchment paper, but I'm going to teach you how to use it without the parchment paper. So here we go. I'm going to do a slide x plus 4. So I'm going to pick this point C because it's leading the way. I know I'm going to go right and up. So I'm going to ever so lightly, I'm going to draw a line x plus 4 and y plus 2, ever so lightly. And I'm going to place my dot C prime here at that location. Now, I could do that for every point. Over 4 up 2. Over 4 up 2. And I want you to notice that I have a triangle, same shape, same size. I just moved each corner right 4 up 2. Okay? And I'm going to go ahead and label my coordinates. Now you'll notice that I have a little mark above A, B, and C because that's called that it changed a little bit. Okay? Now, you should have your triangle in the same spot as mine. So let's go ahead and do step 2. Step 2 asks you to flip over the x-axis where y equals 0. Okay? Now what I'm going to do is I'm going to draw a dotted line on the x-axis. I'm going to put this nice and dark. I'm going to take note. Okay, here's the x-axis. Now, when you have a mirror, it is going to reflect the distance you are away from the mirror. So I notice point C prime is 2 away from the x-axis. That means when it is flipped, it is reflected over that axis. It is also going to be 2 units away. C double prime. And I'm going to do that with point A and B. I'm going to say, okay, here's A. It is 2 away, so I'm going to move it 2 away. There's A double prime. Now notice I'm going to change for B because B is much further away from the mirror. So I'm going to notice that B is 5 units away from the mirror. That means that it is going to go further from the mirror down here. And notice I have my new triangle that has been reflected. Okay? You should have your triangle where I have my triangle. All right, last rigid transformation, number 3, we are going to do a rotation. A rotation, 90 degrees, counterclockwise, at 3, -2. Okay? Now, this is important because I need to think about where this triangle is rotating. If I took this parchment paper, you don't need it. You can just watch for a second. Notice how the image changes depending on where I put my point of rotation. If I put my point of rotation here at A and do 90 degrees counterclockwise, my image looks like this. If I do point B and do 90 degrees rotation, it looks like this. Different. But notice I need to use point C. Point 3, 2. I'm going to put a little circle around it. And I am going to pick a straight line off of this. This is a diagonal line. I don't want to use that diagonal line. I want to use this straight line. And I want to bring this 90 degrees right there. That's where I want that line to end up. Now, I know that it starts at C and it heads towards A. How many units does it head towards A? Well, it heads 4 units. So I'm going to draw a line 4 units down. 1, 2, 3, 4 units down. And I know this is A triple prime. Okay? Now, I notice that I also have this diagonal, but I'm not really sure where that diagonal heads. But I do know that the distance between A and B is 3 units. And I notice a 90-degree angle right there. So if that's 90 degrees, I know this is 90 degrees. 1, 2, 3. And now I can see my diagonal. B triple prime. Now, spatial awareness is a really important thing, especially when you learn to drive. Okay? And spatial awareness helps us get places. Be aware of road signs. Be aware of other cars, other vehicles, how much space you have, how fast you're going. All of these things are beginning to develop as we talk about this type of geometry. I'm going to write down my final coordinates. A triple prime is at 3, -6. B triple prime is at 6, -6. And C triple prime is at 3, -2. Something I want you to observe. Have any of these triangles changed shape? Nope. They all look like the same triangle. Have they changed in size? Did they get bigger? Did they get smaller? Nope. They look the same. The only thing that changed when you did a slide, it changed place, but it kept its orientation. When you do a flip, notice the orientation changes. It's pointing in a different direction. Same thing with the rotation. The orientation changes. We need to pay attention to that type of detail. Okay? Thank you for coming to lesson 6.1.2, doing problems 6 and 8. Talking about these rigid transformations. Thanks for coming, and please continue to be responsible and stay on top of your work. Till next time.